So good morning or good afternoon, depending on where you're joining from. My name is Brianna DeLuca, and I'm a Senior Field Marketing Manager for the Northeast and New York Metro region. And I will be kicking off the webinar and introducing the speakers before they go into their presentations and demos. So today we will be talking about controlling cloud costs with Terraform Cloud Business Tier. To do that, we have Michelle Greer, who is the Terraform Product Marketing Manager, and Kyle Rudy, who is the Terraform Product Marketing at HashiCorp, joining us to talk about how Terraform Cloud, business tier modules and private module registries, policies, and audit logging all contribute to helping your organization manage cloud spend. So following the presentations and demos, we will have a live Q&A. So throughout the presentations and demos, please feel free to put your questions in the Q&A portal, and we will answer those with Kyle and Michelle during the Q&A session. I also wanted to note that the webinar is being recorded, and the recording will be made available after post-processing, which typically takes a day or two, and I will email it out to all of you. So with that, let's go ahead and get started. You can take it away, Michelle.
Okay, thank you very much, Brianna. So why are we here today? Hopefully you're trying to control your costs on cloud, and if that's the case, you're obviously not alone. The average enterprise uses on average 5 different clouds, and that's 3 for production and 2 in dev and test. And so, you know, that's a lot of infrastructure to manage. It costs a lot of money. So enterprises, it's estimated that they spend $39.5 billion in infrastructure, and 14 billion of that is wasted. And so how is that wasted? Well, some of it's idle, right? Somebody provisions something and then they never use it. It could be orphan, you know, there could be a project that never really went anywhere, and then somebody just forgot to deprovision the infrastructure, and so it just ends up being excess cost. And then perhaps the most common form of wasting money is oversizing cloud resources. You know, it's just easy. You know, if you're trying to scale something up or test something, you know, rather than deal with any kind of performance issues, just, you know, oversize the cloud resource, you know, and then not really test it moving forward. So, you know, this is definitely a problem across the industry. And so that's why here at HashiCorp, we've built tools to solve this. So let's get into why this exists, right? So before the public cloud, operations were just a different ballgame entirely, right? You know, a way long time ago, you might actually be racking up a server. But, you know, for the most part, you know, you might provision something, you know, with virtualization, you know, sizing up, sizing down was a fairly manual process. And so operators really were gatekeepers for infrastructure. And so you could really keep better tabs of like how much you were spending. So public cloud changes all of this. Now we see infrastructure that's highly scalable, it's ephemeral, it's across different clouds, right? You know, it's not unheard of that, you know, somebody goes from, you know, T1 Micro to XXL. It's fairly easy, right? You know, provisioning, you can provision very simply from, you know, a console. Infrastructure is also ephemeral now. So, you know, you provision something, you scale up quickly, and then you can deprovision very quickly on demand. And now we also use multiple clouds. So a lot of this started on AWS. Now we see Azure, we see Google Cloud Platform, but we also see all sorts of other services that various teams might use. They might use, you know, platform as a service like Heroku. They might have databases as a service. So there's all this infrastructure to manage that we really didn't have to deal with, you know, just 10, 15 years ago. So the other concern that we now have is anyone can provision infrastructure, right? Anyone with a credit card who can log into a management portal can provision infrastructure. And so, you know, the fact that other teams besides operators are provisioning their own infrastructure is also something that you have to consider when you're looking at your costs. So when defining a strategy for managing all of this in this dynamic environment, what do you need to consider to do, right? Well, there's three primary steps in building this strategy, right? First, you have to define, what are we trying to control, right? Like across what environments, what teams. You need to have different rules for that, right? Like what are we trying to get people to do? Secondly, you need a means to enforce those rules, right? Like there's no point in asking people to set up tags if you ask them to do it and then they don't do it, right? And thirdly, you need a way of viewing how effective this strategy is across your organization. So what does this mean exactly, right? How do you define best practices for cost management, right? So first of all, how can you gain visibility into your infrastructure, right? That's a key part, right? And that starts with setting up the strategy up front while infrastructure is being provisioned in the first place. How can you ensure people are not over provisioning? It's something really easy to do. You especially don't want certain teams over provisioning because, frankly, there's a lot of teams that don't understand the ins and outs of infrastructure. So, and then also, how do you make sure that you're decommissioning your infrastructure when it's no longer needed, right? A lot of organizations have orphan infrastructure, idle infrastructure. How can you make sure that you're not spending money on infrastructure that's not making you money? Right? So what does enforcement look like? Well, as we mentioned before, making sure that you're tagging your infrastructure as you provision it is a key way to view what is actually out in the wild later. So using infrastructure tags is important. You also might want to make sure that when you're doing testing and staging environments that you're using the right sizes, right? You don't want to provision the largest instance types for something that isn't really making you money. It's just, something in test. Something that people also often like to enforce is, making sure people don't provision after 5 p.m. or on the weekends. It's easy to let infrastructure get away with you if nobody else is really watching what's going on. So, having a policy of that is very common across different teams. And then also, you might want to make sure that there's cost estimation thresholds that are not being exceeded, right? Like a lot of these enterprises have different budgets in mind for how much they're supposed to spend. And, it's pretty easy to let that get away from you. So making sure that that's being enforced at every single level is, how to make sure you stay within your budget. So what are different views that you might want to define? You might want to see, all right, what are all of our EC2 instances? What is the infrastructure cost associated with different phases of application development, right? Like you might want to say like, hey, we're spending a lot of money on test environments. Like maybe we want to make sure we're not over provisioning there. And then you also might want to view the costs associated with a specific type of application. So HashiCorp, is obviously a company that knows operators very well. This is something that many of our customers have to deal with every single day. And so, the nice thing about Terraform is when you're provisioning infrastructure as code, you can actually integrate cost control best practices into your workflows themselves. And so we're going to get into that here moving forward. So these are features that are not available in open source, but if you're using Terraform Cloud and the higher tiers, as well as Terraform Enterprise, you can definitely instrument this in your workflows every single day. So these two editions of Terraform, Terraform Cloud is remote, and so it's something that we host for you. Terraform Enterprise is on-premise for larger organizations. The three key features for implementing some of these cost management strategies, one is your private module registry, right? Modules are a key way of implementing best practices across your organization. By using either one of these editions, you can actually set up modules that use these best practices, and then those best practices are then brought on to other parts of your organization because they're using the correct modules. Another key feature here is cost estimation. Before you run a Terraform plan, these different additions will actually estimate the cost of that apply, both on the hourly and the monthly basis. And then another key part of this equation is Sentinel. And Sentinel is policy as code. So, you know, just as you might want to define those best practices, Sentinel is what allows you to enforce those best practices. So how does this work in practice, right? We talked about Terraform modules. You know, like if you see here in this example, you'll see, you know, different tags set in place. And here's how your private module registry actually looks in practice. And so you can have different modules set in place with different tags. And so say Kyle is managing all the infrastructure for our company, and he's tired of me, the developer who is, you know, using a different, who's not tagging infrastructure that other people are provisioning. He can set, instead of like harping on me and getting upset about it, he can set up a module that I then use, right? And so when I use that module, you know, I see the tags set in place, and then I will then also use those tags. I will also tag my infrastructure. So that is how you define those best practices. Now we're going to talk a little bit more about enforcement. And so if you haven't looked at Sentinel, you probably should. It's available in the Terraform Cloud governance and business tiers. And so this just allows you to set hard and soft policies that everyone in your organization must follow. And so, you know, if somebody, say Kyle sets up a policy that says, you know, Michelle, you can't use this huge instance for your test environment, and then I try to provision that, Sentinel can see, okay, that's a test environment, that's the largest instance, and I'm not going to actually apply this change. And so, you know, this is a way of being very proactive in how you're enforcing these cost management policies. Now, thirdly, you'll need a way of viewing this, viewing cost management strategies. And so you can do this both at the practitioner level and at a higher up level. So the way a practitioner can actually look at cost management is with the cost estimation tool. And so say I'm going to provision you know, a database, I want to see how much it's going to cost our organization. Cost management, if you set that up in place, you'll be able to see how much that database is costing on the hourly level as well as a monthly cost. And so, you know, it makes practitioners a little bit more mindful of what they're provisioning and how much that costs. You can also see, if you set up tagging correctly, you can see a lot of what you've provisioned in the outputs of your state file. So be sure to make, if you look at, like if you look at Terraform Cloud and Terraform Enterprise, the state file is shared. And so you can actually see what is being provisioned across your organization. So just to recap, if you're using the systematic approach, first define best practices in Terraform modules. Secondly, enforce those best practices using Sentinel. And third, view how much that your infrastructure is costing you with your Terraform state file, as well as the cost estimation feature. So with that, I'm going to pass it on to the fun part. This is where Kyle is going to show you a demo of how all of this works.
Awesome. Thank you very much for that. Let me see if I can switch over to my screen. There we go. Okay, so we're going to walk through a couple different use cases on how we can use Terraform to really, determine and figure out some of the costs that are associated with our environment. However, when I say costs, and really, what Michelle was discussing there is that not only does it come down to, the dollars and cents, as it were, but this is also about standardization and applying this across different areas of your infrastructure to have those kind of standards applied and achieved. So let's take a look at our first workspace here. Just a very random workspace that sets up a website that displays different pictures of cats, hence the HashiCat. It happens to be using Azure on the back end. And so we're going to kick off this queue. So this is going to go through the plan process, basically saying, okay, we need to deploy some resources. This is what it's all going to take from Terraform in order to make these things come to life. So here at the end of our plan, we can see that there are going to be 9 new resources that are going to be added as part of this infrastructure configuration that we're applying. Then it goes into these next 2 sections here that are really why we're here today. The first of which is cost estimation. So what the cost estimation piece is going to do is it's going to reach out to Azure's cost estimation API, and it's going to pull back some information about some of the resources that are being consumed as part of this configuration. So as a result, we can see that there are costs that are associated to 2 of those different resources, one of which being the Azure Managed Disk, as well as the virtual machine itself. Now we can see, there might be some considerations here for if you're deploying this in your own environment. Like, do we really need to have premium SSD for these managed disks? If we look at our cost, these are list rates here. So, the monthly cost is going to be $135 just for the disk, whereas the virtual machine is only going to be $14. So, maybe that's something that you want to put into consideration, as you're running through and trying to optimize your costs. So, end result here, we can see that 2 of the 4 different resources are going to end up being about $150 a month. Maybe that's worth it for this application if it's production. Maybe if it's something that's an internal app or in development, maybe not so much what we want to do. But then on the next section is where we get into Sentinel and applying some policy as code based checks. So here we have 3 different rules that are set up. Our first one is just around costing. Now, we kind of just walk through that so we can see why we would have an advisory failed for that. But then we also have some other rules. The other one is around timing, meaning that, let's see if I can pull out there it is. So we can see some output from the verbose logging here that it's checking to see if it's read-only Friday. This webinar is being recorded on a Monday, so we're all set from that aspect. It passes. We don't want to have anybody deploying things on a Friday and then, it runs all weekend and nobody's really using it or accessing it. Then our last check right here is coming from a different set of policy checks. And this is checking to make sure that we're using the proper instance type. We want to make sure that in this case, we are deploying, if I scroll up to the appropriate area, we are deploying a VM size of standard A0 for our Azure configuration. And then, because it's only an advisory failed, so that means that we can push forward if we want to. But depending upon the roles and permissions that are assigned to you. In this case, we're not quite ready to apply this. Some different things have been handed down from our security team that really want us to take a look at integrating some more of our, some more rigid standards around our security process and the things that we're applying to our resources that are being deployed. So one of the really cool things that we can do with Sentinel is import some rules that have been configured for say, the Center for Internet Security. So if we go down to our policy sets here, this is where those Sentinel rules are being applied. So we have our general policy set that was applied in the middle. Then we have our Azure based policies. But here up top, this is talking about some foundational policies. These are some policies that have already been written by us at HashiCorp that align with certain different standards. So let's jump out to this GitHub repository. Right here, it's the Center for Internet Security, and we've already created some different rules for AWS, Azure, and GCP. So we're in Azure, and we're trying to be more secure about the managed disk that's being applied. We already know that that CIS has a particular standard that's been established for it. It's CIS 7.1. So it's just ensuring that all the managed disks are encrypted. So instead of having to create kind of a more verbose rule ourselves, because on the back end, Sentinel rules are written in a programming language. So we can define those to be as complex or as simple as we will really want. However, we can make use of this source parameter here that's part of this that points out to this particular rule for CIS 7.1. So let me copy this out here, and then don't blame me. I'm going to edit this in GitHub, which I know, bad touch, not what we're supposed to be doing, but for the sake of time, I'll just go ahead and put that directly in there. And say that we're adding a CIS 7.1 policy check. Now, then again, bad touch, I'm committing it directly to our main branch instead of creating a pull request. Again, for the sake of time. So now if we go back to that HashiCorp Azure workspace here, if we run another queue plan, we'll check to see, is that managed disk encrypted? Yeah, so this will take a couple more seconds here. So we can see that the configuration hasn't changed. The output of that is still the same. We're still adding 9 brand new resources. Cost estimation should also not change because we haven't changed our configuration, but the policy checks are where it really comes into play. There we go. And so here we have 4 different policy checks because these Sentinel rules from the policy sets are being pulled in from that GitHub repository. We can now see that we have, again, our costing has failed, but then here's our CIS check. So we've able to pull that information directly from the foundational policies and applied that directly to our workspace, in no time flat. And we can see that, like, wait, what? Our disk is not being encrypted? Like, that's kind of a big deal. So immediately we can gain some value in seeing that, our configurations aren't exactly to the standards that we thought they were. So again, we're going to discard this because I don't want to cost any more money with this configuration. But we can also check out some of these other areas. So, we were just looking at Azure. So what happens if we look at, say, this other resource that was created in AWS? Nope. Nothing that's part of the cost estimation. However, we can see some of our policy checks here because we can apply these across the various different services. So it doesn't matter, you can write ones that are specific for Azure, or you can write them in general for your environment to take advantage of. And in this case, this one was being ran when our timing was going to be an issue. So that means that this was ran on a Friday. So this is obviously going to fail. All right, so let's get into some other things, some consistency, how do we manage all of these environments? Like, this is just one demo environment. We have 11 different workspaces, but we're accessing, we have some Azure resources, we have some AWS resources, and then we also have some on-premises resources for a VMware environment. Well, but how do we manage those things? How do we make sure that the people who are gaining access to our Terraform Cloud environment are being able to interact with, create, deploy, and manage the things that they're supposed to? And here with Terraform Cloud and the business tier, they've added some really neat functionality around SSO. So here we have a built-in integration with Okta, meaning that we can, create and set up our Okta environment so that, we can manage the users accessing Terraform Cloud through Okta, so we can transfer all that knowledge that we've established with Okta in the way that we, assign users to different groups and teams and have various different access levels. And we can do that with Terraform Cloud as well. So in this case, we've set up and imported a couple different users. One in particular is going to be my own personal account here. So we can see that there's a little bit of a difference. It's kruddy at Okta Preview. So that's pulling directly in from our Okta situation or configuration. And we've assigned it to the AWS team. So with that, we can go back to our workspaces and see that this user can only access our AWS-based resources thanks to some additional team access that's available at the workspace level. So here we have our AWS team that's been assigned. We can give them, oops, didn't want to go to that one, wanted to go to this one. So we can give this team all kinds of different permissions so that they can either read, they can just do simple plan operations, or they can do the whole thing. They can, create, deploy, and manage the entire system. We can even get a little more granularity with that by customizing the permissions for this team, but that's a little bit above and beyond what we're doing here. So the next thing that I kind of want to get into here is about some of the visibility and how that kind of works with some of these environments. So another really cool addition that was created as part of the Terraform Cloud business tier was this concept of audit trails. So this is an API service that's out there, available. It's REST-based, pulls back JSON-based information, and then we can kind of pull through that information to see what's happening in our environment. This is extremely important to gain that kind of visibility that we really demand from our infrastructure sides. So by default, this is an API service. So there's no like firewall rules that need to be set up. This is a service that's reaching out to Terraform Cloud and pulling that information back. So it's really nifty in that aspect too. Now, one of the things that we've done is created an integration with Splunk, meaning that we can have Splunk reach out to Terraform Cloud and pull back all kinds of information in order to make that, give us that visibility that we're demanding. Here, let's update our dashboard here. As part of the Terraform Cloud for Splunk application, it includes this dashboard, which can give us some really great information. So we can see some, 38 policy checks have been performed against this environment. We've probably done some things that we shouldn't have. There's 10 different overrides, and there's 27 runs applied. All different kinds of information that we can see and kind of gather better information and visibility into our environment. Now, these are just the dashboards. We can also go and use some of the native search Splunk searching capabilities to say, let's see, policy. Pull up some of the policy checks that have happened in this environment. Let's see if we can pull out some cost estimation. So we can see that when different actions are performed within our environment, we have the ability to see that this was a cost estimation task. This was run by my user account against our organization ID. And let's do, let's check the important one here, because this was in the dashboard, that override. We want to see, if people are going through in their environments and they have configurations and then they're still performing an override, like, we want to know. We want to see what's happening here. So we can see that there was an override that was happening as part of a policy check. We know exactly what the request ID is, and we even know which user performed it. Again, bad touch for me here. Keep overriding things. Should write my my configurations more in alignment to what my organization is has defined. You know, we can build out all kinds of other information. We can even use some of these dashboards to go ahead and filter through some of the results that have been happening. So here, we just performed a couple different policy checks. We can see that they've started to populate inside of the Splunk interface. These are basically real-time readouts of what's happening in your Terraform Cloud environment. So the next big thing that I want to talk about here is this goes back to standards and making sure that everything, everybody's using the same types of configurations, same type of process. So we have these two different workspaces here that are assigned to on-premises based environments. So this first one here is going out to a vSphere environment and trying to deploy a template. So if we go ahead and queue this plan, without any types of other modification, it's trying to reach into my on-prem environment, my lab environment. Now, this lab environment doesn't have communication out to the internet. So we can see here, right, almost instantaneously, it says, hey, we can't reach your vCenter server that you've assigned to this. So that's an issue, because either we need to open up some firewall rules, or we need to do some other magic that, generally security teams aren't that happy or excited to really comply to or aid us with. So we've created something that's known as the Terraform Cloud agents. So here, if we go back to our organization settings and then drop into agents, we have some agents that are out there, and we can run these systems as Docker containers and make them available within different on-premises environments. So in this case, I have these two agents that have already been deployed just for the sake of timing. And I've given them names of Terraform Cloud agents in Nomad. And so I'm using Nomad as my on-premises Docker orchestration tool. So if we jump over to our Nomad environment, we can see that we have two different agents that are running, and really kind of the magic behind what these agents are doing, because we don't want to create additional firewall rules, because, security teams never like that. It's never fun having to go through that, that whole process of whitelisting those. So what's happening with these Docker containers is that they are literally reaching out to Terraform Cloud with an agent token and saying, do you have a job that's ready for us? Reaches out every about 15 seconds, as you can tell here. And the output is, roughly the same on both of these. So let's head back to our workspace and try and deploy our template again. However, we have to update our execution mode. So for those of you that aren't familiar with Terraform Cloud, there's a couple different ways that we can apply our infrastructure as code configurations to our various environments. So we have remote, and remote is going to be kind of the default mode when it comes to Terraform Cloud. That means the Terraform Cloud manages the entire Terraform initialization, formatting, planning, and apply process. Basically the entire workflow or life cycle workflow for your environment or your infrastructure. Then we have local mode. That means that we want to run Terraform from our local CLI configuration, kind of manage it ourselves. Then we have this new, like brand new agent execution mode. So if we update this within our workspace, save our settings here, we can now queue up our plan. Now our plan is going to be simultaneously streamed both in Terraform Cloud as well as in one of these Nomad agents. So let's see if we can, there we go. Picked up on the first agent. So we can see some things like up top, it reached out, it found that it had a Terraform plan to run. Then we can see that it's going to create a virtual machine as part of the plan. We can see all the little pieces within that, including that it's a clone operation, our disks, our network, and then the plan is to add one new virtual machine to this environment. So if we go back to our Terraform Cloud console over here, we can see that we have continued through, we're still going to plan to add one new resource, cost estimation finish, but because vSphere doesn't have any APIs that are associated with that estimation, nothing shows up. But then we still have our policy checks here. These policy checks still ran and still checked. Even though costing isn't going to be a huge selling point on this one, but the timing still is. So we could see that, again, it's not read-only Friday, so we could still deploy this configuration. So we're ready to hit the confirm and apply. So we've confirmed that we do want to create this virtual machine. We can see that the apply is kicked off. So let's see if we can figure out which one this runs on. It continued to run against our very first agent. Now we can see that the creation process has now begun. If we see the second to last line. Then if we jump to our vSphere environment here, we have a clone operation that's happening. We can also see that in our side panel here. It's being run by our service account that we've assigned to Terraform as part of our configuration file. And then our Nomad agent, it's a Docker container. It's running in Nomad. It's going to continue this deployment process without any requirements from me on our side. Now, a lot of what I've shown so far is all using the Terraform Cloud console. But I mentioned that whole local mode, meaning that we could still take advantage of all the things that Terraform Cloud has to offer while still using the CLI. I'm kind of a creature of habit, so don't like change a whole lot. So let's switch over and use the CLI to now deploy perhaps a folder structure. So as part of this, we're initializing a backend. So we're telling Terraform our local configuration file here that we want to use Terraform Cloud as the backend. So we can see that we've successfully configured the backend. So that's going to be where we store our state file in an encrypted manner. It's transmitted securely as well. And then we're going to use Terraform Cloud to also make use of that Terraform Cloud agent. Because instead of running this off of my local system, maybe I'm somewhere else. Maybe I don't have direct connection to my vSphere environment. So let's do a Terraform plan. Let that run. We can see that, the running plan is in the remote backend, but the output is still going to stream to here. Oh, look, it still failed. It says that we can't reach our SOAP client. So let me see if this is a me error, or let's make sure. This is our folder structure configuration here. Nope, it still has remote. So it was going out to our remote Terraform Cloud environment, and it's still trying to reach our on-prem environment. We'll just update this to agent really quick and run this again. So here, since we already have one agent that's out there and running, this is kind of the nicety behind these agents and the ability to pull these agents together. So we have this one, it's still deploying our virtual machine. So let's check in on our second one. We can see that it's updated. It has a plan here for 8 different items that we need to deploy or add to this vSphere environment. And then at the end, it goes right back and says, okay, we're reaching back out to Terraform Cloud. We're ready to run some other jobs or configurations. We can still continue to see the output from our policy checks, even when we run it locally, so we know exactly what's happening. We have that visibility directly within our local interface as well. So we're just going to run the whole process. I don't want to be approved. I just want this thing to roll. So it's going to wait here. It's sent itself out, sent the job out to Terraform Cloud. Now we're just waiting for the one of the agents to pick up the job in order to start processing it. So there's our Sentinel policy checks that have completed, and then now we should kick right into the apply process And we should see our recent tasks start building out some folder structures. The concept behind this is that we want to really deploy a new environment, and we need a folder structure to support it. I forgot to really go over that piece. So now here over off to the left-hand side, we can see that this Tampa folder has been created. There's database folder, file servers, management, web, standard build out for most on-premises environments. And then we can even take it a step further and look at our management folder. We've included a bunch of other folders there as well. So, we've been able to take advantage of this agent. It continues to run and access even though our other agent is busy trying to deploy some things. Now, the one thing before I turn it back to Brianna and Michelle to start the Q&A is I want to show this usage area as well. This is kind of new for Terraform Cloud, in particular the business tier users. So we kind of have a really good viewpoint. You're not just limited to our Splunk dashboard through that application, but we also have some idea of what's happening from Terraform Cloud itself. So we can see some of the successful applies, we can see how many users there are. And then the other neat thing, because what I showed without really talking about there was the ability to do concurrent runs, meaning that, in most configurations of Terraform Cloud, minus the team and governance tier, which now can go up to 2 concurrent runs, we can do multiple different runs all at the same time with the Terraform Cloud business tier. So that really speeds up the process of deploying and managing our environments as well. And our template is still deploying, but we can check out our folder structure here, and we can see that our state is also being managed in Terraform Cloud. That's not something that's unique to the business tier specifically. This is also available for those taking advantage of Terraform Cloud in the free tier. So with that, let me send it back. Let me stop sharing my screen here if I can find where that button is, and turn it over for some Q&A.
Awesome. Thank you, Michelle and Kyle. So we had a bunch of questions come in throughout the presentations and demos. So if we don't get to your question, we'll be sure to follow up and get you the answer to it. So let's just get started. So the first question is for Michelle. So comparing Terraform with other industry orchestrators, what makes Terraform really stand out? Michelle, I think you're still on mute.
Sorry about that.
No worries.
So how are we different? Yeah, I mean, it's just the idea that I think Terraform is really key around provisioning. I think one of the biggest strengths of Terraform is its ecosystem. We allow you to provision over 200 different cloud providers. So that includes different, all the major public clouds and public services. I think Terraform also has the ecosystem going for it in terms of the community, right? We have over 1 million downloads. It's one of the most requested skills learned for operators. If you look at a lot of different surveys, if you look at, I know Stack Overflow does a study every year about what people are looking at. And so, yeah, I think, those are some key attributes for it. A lot of practitioners definitely talk to us about, they just like the simplicity of the workflow. We definitely have a lot of people moving from something like CloudFormation to Terraform, one, because it's multi-cloud, but two, it allows them to handle things like dependencies a lot smoother than other different, other infrastructure as code tools. And so, yeah, I mean, I think there's a lot of momentum going for it. I think there's, multi-cloud is definitely key. And yeah, I mean, if you go to learn.hashicorp.com, have a look at it, look at the syntax, you'll see it's, it definitely handles a lot of issues fairly smoothly because our open source product managers definitely listen to the community every single day. So those are probably the key differences.
Awesome. Thanks, Michelle. Another follow-up question was, can you talk about the main differences between Terraform Cloud and Enterprise? Is it just a cost difference, or what are the main differences between the two?
Yes, so Terraform Cloud is run remotely. We actually host it for you. So when you do a Terraform run, it's actually being performed on one of our servers. You know, for most organizations, this is fine. Terraform Cloud is also, it starts off free. So if you go to terraform.io, you can actually sign up for free, have a look at it. Now, the specific features we were looking at come in the business tier. And so that's something that you'd want to talk to a salesperson about, because, you know, the pricing definitely varies on the size of your organization. Terraform Enterprise is something that your company will provision like on premise. And so it's especially good for if you have, you know, a lot of restrictions in terms of compliance and security. A lot of organizations can't use anything in the cloud. And so they set up Terraform Enterprise. In terms of the features, they're near parity. And so at the moment. So yeah, I think a lot of it just depends on, your organization's needs.
Perfect. Thanks, Michelle. Okay, this one was for Kyle. Is there a way to check my infrastructure utilization? Is there any option to automatically grow my infrastructure at peak times and bring it back down automatically when I don't have much utilization?
It depends on the service. I mean, the answer, unfortunately, there is the always fun answer of it depends. It depends on how your configuration has been written. It depends on the service that it's using. It depends on the providers that are being accessed. Is that something that's built into Terraform Cloud and Terraform Enterprise itself? That isn't something that, you know, is just like one of the settings, so it's not there. So that is something that you have to take into consideration with your configurations and how they're being deployed within the services that you're accessing and deploying on.
Perfect. And then another question was, when you were writing the listing out the rule sets, does order matter when doing that function?
I'm assuming that we're talking about the Sentinel rules, and no, all of the rules will be run independently. So it doesn't matter. So like if one fails, it's still going to run whatever else is there. So you get a good visibility into the complete rule set instead of just, you know, failing one and you're done.
Yep. Is the cost estimation feature only available through HashiCorp Cloud? They have Terraform in a VM. Are they still able to use that feature?
So it is, so cost estimation is available for both Terraform Cloud in, I believe, the teams and governance tier, as well as within Terraform Enterprise as well. So if you're running the on-premises version or, you know, self-hosted version, it's available there as well. What Terraform Cloud does, it kind of has a nicety because it has, you know, public access to a lot of those public APIs for the costing, whereas with the self-hosted version, you know, you might still have some of those firewall rules. You might have to supply it some tokens in order to interact with those services. So keep that in mind if you're already using the self-hosted option.
Perfect. So they saw you were using Splunk, and someone had asked, do you need a separate subscription for Splunk? And if so, are there any other options besides Splunk?
So right now, the offering that we have, the integration that we have is with Splunk today. That is something that you have to be a Splunk customer of either their on-prem, their self-hosted version, Splunk Enterprise, or it also now works with Splunk Cloud. As far as other integrations, if you have any suggestions, if there's something that you're looking for, please let us know in the comments or in another question. But right now it is just Splunk. However, because of that audit trail service that I was talking about, if you have some sort of utility that can reach out to an API service, you can definitely consume those audit logs through that method as well. it's just a REST service. And as long as whatever application that you're using can read JSON, you're set.
Awesome. And then someone had a question about your CIS checks. So do you have to include them one at a time, or can you include them all at once?
So for the Center for Internet Security checks, those are the ones through the Foundational Policies library. Those are individual checks, but what that really comes down to is just copy and pasting those like 4 lines of code and putting it into your own rules. Some of the things that happen there, you don't want to apply all of them because you kind of want to have an understanding of what's being applied, what's being checked. And that gives you some additional granularity to change what kind of enforcement levels there are. So whether or not that's like a warning level, a soft mandatory advisory, or a hard mandatory advisory, it gives you that granularity to have a choice in the way that those rules are applied. Like I would hate to have, one of the rules is around applying of tagging to AWS resources. Like I would hate to have a configuration fail because I didn't tag every single piece of my infrastructure. But that could be something that you apply to everything in your environment. So that's the other case, that it's also kind of environment by environment.
Awesome. Another question came in. If you run the configurations on your infrastructure, what kind of security measures are being used?
Yeah, well, that's a lengthy answer. So it kind of goes back to the depends on what we're really talking about here.
Yeah.
So a lot of things that it's going to come down to is like for our VMware environment there, it was using a service account that I created. That service account had to have the appropriate permissions in order to be able to create folders and to be able to create a new virtual machine based on that cloning process. So, in that case, it was creating a user account and providing it with the permissions in a manner that doesn't allow other people to really be able to check out those different, those credentials. Then on the Azure side, we have different IDs that go along with that. So that comes down to kind of looking into and viewing the RBAC model or role-based access control for that particular service. And the same thing for AWS, same thing for Google, same thing for pretty much everything else. Generally, there's going to be some way that the Terraform provider reaches out, connects, and authenticates to those individual services. And a lot of times you're going to have to provide certain permissions at that service-based level in order for the Terraform configuration to run.
Thanks, Kyle. Is Terraform planning to add resource configurations for on-premise extended cloud services like Azure Stack, AWS Outpost, etc.?
So I feel like a lot of my answers here are it depends.
Yeah.
But I think what you're going to see is it's going to vastly depend on us, two, the service, and then a lot of customer demand. So we've done really well from the HashiCorp side at creating providers for AWS and GCP and Azure, and even the vSphere providers was created and maintained by HashiCorp. So I think you can probably figure out that you're going to see a lot of those providers come into play. But again, at the same time, these are open source providers. So if AWS wants to come in and start working with Outposts and creating a provider for that, absolutely, we're more than happy to approve those pull requests. Same thing for VMware Cloud on AWS. Same thing for basically any service. As long as it has a provider, it has some sort of SDK to reach out and interact with. Like we can basically provide a provider. It's just figuring out, at that point, making sure that it's going to be something that's going to be used and it's something that makes sense.
Great. Okay, this is the final question, and then if we didn't get to your question, we will follow up with an answer. But so, can Terraform Cloud integrate with K8's platform? For instance, if you create a K8 cluster and apply security policies that can be integrated with console?
It depends. So there is a Terraform or a Terraform provider for Kubernetes that's out there and available. There is also the Kubernetes operator that's out there and available. Both of these can be integrated with Terraform and Terraform Cloud and Terraform Enterprise in order to be able to manage those Kubernetes-based environments. So it kind of just comes down to how you want to manage your Kubernetes environments and what these providers can do and how they can add value to your environments.
Perfect. Okay, that was the last one we'll take. I want to just give a huge thank you to Michelle and Kyle for presenting today and demoing, and to all of you that joined. Thank you for spending some time with us. And as I noted at the beginning, this was all recorded, so I will be sending it out after post-processing, which usually takes a day or two. So with that, we are good to go. Thank you again, Michelle and Kyle.